umbilical today? True. I can. I think that's near the house written. I think it is.
Main umbilical is on Drew's column.
Okay.
Coming up.
Thanks.
In a little bit. First, it's the TA.
And the TA is coming down.
All right.
MTA is down and locked. Handle is secure.
Congratulations. P105, 106, cover next.
I hope we didn't knock those things off. Right on top of me, and they're both still there.
That's good news. Now, inspect the main umbilical.
Delmandu. Yeah, what do you call that map?
For Tomas Gonzalez Torres,
Yes.
Ombligo del Mundo.
Yes, I'm tethered to the L-gap C.
Copy.
Pushing the plunger.
Okay.
Rotate it out. Yeah, I see in the umbilical.
You can, it's dark out, Drew. It's hard for us to tell.
Can you see there at all?
Stand by.
Yeah, not really. I can put the other side of my head in, but the
Hey, don't strain too much. If you could just try again.
select my right camera.
Maybe move to the left a little bit if you can. Maybe a little more left. A little up if you can, but you're underneath the telescope, so you probably can't.
Okay, now I can see in there.
How is it?
Nothing in there. This should be.
Copy. Ombligo del Mundo, bueno. That was for Tomas.
Oh, yep, she's coming out. Tip pin stowed.
Copy, John, thanks.
A little tight.
Drew, the next thing we have for you is the BAPS post pins.
Copy.
But we're going to wait until John finishes his L-gap C, unless we get different from the ground, so stand by.
Standing by. I'm going down. That's the low gain cover antenna.
Be careful.
Yep.
Let's take our time, John.
Yep. Giving one last handshake to Mr. Hubble for me. Okay, I'm off the telescope.
Copy, off the telescope.
Ready for BAPS pins.
Ready for BAPS pins, yes. And we would like a Smith report, please.
Roger. BAPS post pins came out early.
Copy, easily. Now, Drew, you need to check the Velcro is engaged on the BAPS attach fitting clevis pit pins.
At the bottom.
Yes.
That's the L-gap C is in its bayonet. One captive its pin is engaged. Run for the other.
Excellent, John.
Hello, Drew. Hello, John. Mass, the Velcro looks just fine at the bottom.
Thanks very much. Your next will be to translate to the airlock, and as long as you got your tether back from the MFR, no need for an inventory.
I have my tether back from the MFR.
Atlantis Houston for EVA.
Yes, Dan?
Yeah, Mass, could you double check that we also get a Velcro verification at the top of the BAPS?
Okay, on the, I guess on the pins that Drew just stowed?
I think they mean the top clevis.
Yeah,
on the
that's
top
right.
clevis,
Top
Houston?
clevis, that's right. Yes, that's right.
Okay, we'll get that.
Top clevis Velcro is engaged.
Copy, top clevis, Velcro engaged, and
Shuttle Atlantis now over the southern Indian Ocean in that area outside the range of communications with Mission Control in Houston, but we should reacquire in 1 minute's time, and then 8 minutes after that we should get television pictures from Atlantis once again. Spacewalker Drew Feustel has finished up the last of his steps in payload bay cleanup and moving on to final inventory, headed back toward the airlock. John Grunsfeld is believed to be through the last steps of manipulator foot restraint stowing, and if that's the case, he'll be translating back to the airlock on the robotic arm and heading back into the airlock. Also standing by to hear from the Space Telescope Operations Control Center. They should be about ready to start the commanding for deployment of the high-gain antennas on the Hubble Space Telescope. Both of those antennas due to be moved back into position now that the work on the telescope by the spacewalking astronauts is completed.
yeah, make sure. Take your time. It would be a nice ending to get that thing stowed successfully.
Yeah. A lot easier in the pool. I'm still tethered to it. I'm going to release the other captive lock pin and try and get this one first. If that helps. Yeah, we don't want this in the cabin. I'd have to wear it as a hat. Just cut little eye holes in it for you, John. Okay, I got it.
Congratulations, now get out of there.
Okay, I got to get the second one that I opened up.
All right, get that one.
They're both engaged. I'm going to take my tether back.
Okay, great.
Get my,
the pit pins in the pouch?
Pit pins are in the pouch.
That's great. And you already stowed the cutters and roller earlier, right?
Yes, you did.
All right, so you're back to the airlock as well.
Okay.
You can ride the RMS if you'd like.
Okay, I will. I got to go get my waist tether.
Now 6 hours, 14 minutes into today's spacewalk. The spacewalkers have, on paper, about 25 minutes worth of activities left to complete the final spacewalk of this flight.
Okay. Thanks, man. Sorry that took so long.
Very good that you got it successfully stowed.
Low gain and to hold, John. Stop. Thank you. Hey, we liberated a small piece of something off the end of that. Yep, we did. You see where it went? It's under the telescope. Passing underneath. Okay, it's coming back down into the payload bay now. You see where? Yeah, I can see it. It's right by the BAPS post. Okay. Probably even get it.
I don't think it's an issue.
Yeah, I think we ought to get it.
Okay.
Still got eyes on it. Let me go look at the antenna. Looks like a little piece of tape. Little piece of tape? Yeah. I've got it. Oh, no. I hope the antenna is okay. I feel terrible.
Was it the low gain? Almost the low gain?
I tapped the low gain antenna with my twist.
There's two of them.
Nah, I still... Houston, do you have a picture of this?
Atlantis, Houston, we don't have KU right now.
WVS, it's kind of dark.
Okay. I'm sick. Okay. It kind of knocked off the end cap. Going in my trash bag. Okay. You got it? Yep.
And
Shoot.
It's okay, John.
Do you have a wireless video of it?
Actually, Megan was able to figure out how to get the B camera on it, and we got a pretty good shot. Houston, are you seeing that on camera?
I think they said they didn't have KU.
yeah, man, so it'll be about
I'm
another
sorry.
3 minutes or so before we have KU.
Okay, Dan. John, it's okay.
Where are you at, Drew? I'm down at the bottom of the A side. Okay. Clear view. You got it in your trash bag? Yeah, I got it. Okay. Does it look like just a cap? It does look like a cap to me. That black with looks like either epoxy or fiberglass sort of ring inside of it. I'm caught on the slide door. Sorry about that, Drew. You all right now? Yeah, okay. I'm clear. It's back. I'm okay. Okay. You all right? Can you bring the arm closer?
Sure thing, coming out.
Thanks. Thanks for trying to help me, Drew. Sorry, buddy. I started, but it was a little too late. I'm going to stop. Okay. Thanks, Megan. Hold on. Let's get a tether. Friend,
Ready to maneuver, John?
have a good voyage. I'm ready to maneuver, Megan. Sorry about that. I think this is going to be the max heart rate. Sorry, Scooter. Sorry, team. Recover. That LGAP C. Still your nemesis. Still my nemesis.
Yeah. Hey, John, you guys have had a great set of spacewalks. Come on in.
I'm on my way. There's a couple of things I'd like to say if we have the time while we're translating.
Yeah, John, go ahead and say a couple of things, and then I'll close it out.
Thank you. This is a really tremendous adventure that we've been on, a very challenging mission. Hubble isn't just a satellite. It's about humanity's quest for knowledge. There are a few people that are very special to Hubble that I'd like to thank. Lyman Spitzer and John Bacall, both deceased, but without whom we wouldn't have a Hubble Space Telescope or this amazing adventure. Others who are still with us and being very productive scientists, Steve Beckwith, and our President Bill Smith, Senator Mikulski, and Ed Weiler, without whom we wouldn't have a servicing mission 4, and of course, Mike Griffin. I think we'd all agree that without SEPI, none of this would have happened. It's a tour de force of tools and human ingenuity. This mission in particular, as Arthur C. Clarke says, the only way of finding the limits of the possible is by going beyond them into the impossible. And on this mission, we tried some things that many people said was impossible: fixing stiff, repairing ACS, achieving all the content that we have in this mission. But we've achieved that, and we wish Hubble the very best. It's really a sign of the great country that we live in that we're able to do things like this on a marvelous spaceship like Space Shuttle Atlantis. And I'm convinced that if we can solve problems like repairing Hubble, getting to space, doing the servicing we do, traveling 17,500 miles an hour around the Earth, that we can achieve other great things, like solving our energy problems and our climate problems. All things that are in the middle of NASA's prime and core values. As Drew and I go into the airlock, I want to wish Hubble its own set of adventures, and with the new instruments we've installed, that it may unlock further mysteries of the universe. Over to you, Scooter.
And Megan's got a short comment she'd like to make.
Thank you.
Andrew, would you like to say anything?
Well, before I go in, I just want to say that these were 3 fantastic EVAs and 5 altogether with all of us. And I'm just really proud to have been a part of this, and I want to thank everybody for supporting me, especially my wife and kids, Cindy, Ari, and Aiden, for looking out for me and getting me through this, and the rest of the NASA team for allowing me to participate. So thanks, everybody.
Very nice, Drew. Thank you. Go ahead, Megan.
I just wanted to say a few words. The ARM is a supporting player in this action adventure, but there's a few very important people on the ground that have made it a very efficient operation so that we can make the most of our EVA time. I'd like to thank Stephanie and Marco. All of their hours spent with me at the MBL and perfecting the procedures really helped us be efficient. Also at the MBL, Charlie, Robert, and Craig for always looking over my shoulder while I was learning to drive that arm. And of course, Linda as well for all of her help and assistance in the last couple of years. Thanks to everybody, as well as our PDRS lead, Ian, for everybody's hard work getting the arm ready to go.
Thanks, Megan. And sign of a great crew is that the commander has nothing left to do, usually, and that's the case here. I think a lot of great things have been said. I appreciate all the work that we've had together, the coming together from across the country, to support this mission. Really, the whole world watching Hubble, enjoying its downlink of images and the advances of scientific knowledge. It's an incredible partnership that we experienced up here doing the spacewalks with 4 different spacewalkers, arm operators, and taking care of the shuttle. It's been a great thrill. I'm very proud of the crew and also the whole team. Tony Sacacci, Orbit 1, Dan Burbank is Capcom, Rick and Dex, Orbit 2, Shannon, Orbit 3, the planning shift. The teamwork's been amazing, and of course you can't forget the teamwork of the folks who got the shuttle ready to fly down at KSC and across NASA. So thanks to all. We're thrilled that this went so well. We got a few things left to do over the next couple of days, but we're looking forward to coming home and saying thanks to everybody in person. Back to EVA closeout.
Okay, Matt, that was great, Scooter. Scooter, could you do me a quick favor?
What's that, John?
Just go down and check the BSA status for me.
Okay.
Thanks. Matt, I think I'm going to...
You are going in the airlock.
All right, Drew, I'll see you in a couple of minutes. Okay, John. Thanks a lot for the help.
Atlantis Houston for EVA.
You're awesome.
Thanks, buddy. Yes, Dan.
Well trained.
Hey, John, one quick question for you, just to make sure we understand. Did you see any exposed copper at all on the very tip there?
Affirmative.
Hey, Dan, we got a climate Bravo if you want to pull that up. Really good picture of Megan was able to get by moving the camera around for you. It'll probably get better when the sun comes up. You can take a look at it now if you'd like.
Okay, we copy that.
John, the BSA looks great.
Thanks.
And before you go in and complete the rest of the ingress, we would like to stand by just for a moment. We may have one more quick action for you.
Okay.
Atlantis Houston for EVA. The one thing we're talking about, and we're getting close here, just be another moment or two, is we're debating whether to put the LGAP C back on the LGAP from the standpoint of thermal. We think we might preserve the best functionality, so we're still discussing it. Give us just a moment.
Dan, we understand, and actually our commander thought you might say that just before you said it, so that makes sense to us. If you'd like to do that, I'm sure the boys would be happy to oblige.
Maybe that's the best fate for it. Leave it. Hey. Lightning. Like yesterday? Yeah. Angry. Beautiful.
Atlantis Houston, John, we're still discussing this, but we want to make sure that you know that operation of that antenna is still good. We're just discussing whether or not we want to protect it a little bit more from a thermal standpoint. That's the only debate here.
Understand. Yeah, there were two small strips of copper at the end of it. For, you know, 1/8 of an inch by about an 1/8 of an inch. Thanks for getting the cap. Yeah.
Atlantis, Houston, I think we've decided we'll go ahead and have you install the LGAP-C. It'll give us good thermal protection for the antenna. And just so you know, we do have a good signal from it. We're not transmitting from it right now, but it receives just fine.
Why don't you take the arm and I'll go back down the rail and you guys agree in the cabin.
That's fine. Fine with us. Houston, just to make sure we copy, we're going to have one of the guys go back and put the cover back on.
Ready to go, Megan?
We copy and confirm.
And Megan, I can take course rate.
Okay, Drew, why don't you go back there as well?
Thanks.
There quickly.
And Houston, Atlantis, you know, we don't have a real plan for this, but John's going to ride the arm back there, and Drew's going to translate back there. We'll have both of them work on it, okay?
Okay, we copy that.
Stand by, John. I've done this a few times. Maybe once too many.
One additional task now for spacewalkers John Grunsfeld and Drew Feustel. About 15 minutes ago, around 1:35 Central Time, both spacewalkers noticed a small piece of debris floating under the telescope near the BAPS post. And Grunsfeld went to retrieve it, but he told Mission Control that he tapped the low-gain antenna on the underside of the telescope with his backpack and knocked off the end cap.
What do you think, ma'am?
I think it's fine. I'll check. Houston, Atlantis, we okay with the thermal cover open for a few more minutes?
Thanks for about all the tools.
Atlantis, Houston, that's a firm mass, no problem there.
Okay, good.
Thanks, Dan.
Space Telescope Operations Control Center asked for a report from Grunsfeld as to whether or not he could see any copper in the low-gain antenna after he'd knocked off the end cap. His reply was that he could.
I'll do that.
Copy, Dan.
The stock indicates that that antenna is still functioning, but they've decided they have the crew reinstall the protective cover on that antenna for its thermal protection, since the end of the structure of the antenna has been knocked off. And spacewalkers John Grunsfeld and Drew Feustel are undertaking that final task now.
Like a sunrise coming up through. See it. It looks like there's a lot of space there, but apparently not. Well, you've seen me attempt the same thing, and yep. I just caught a glimpse of you at the last minute. I think I just saw a jet fire. Yep, there's one. Do we need to put the back pins in or anything? We just put that on. I don't think so.
I'll check. Houston, Atlantis for EVA. Drew brought up a good point since we're going to be back on the telescope. Do we need the BAPS pins, or are we okay with that? I'm guessing we won't, but...
Yeah, that's a good thought. We're double checking right now. Wait one.
Not trying to create work or anything, but it's not like I'm driving lapses, right?
John, where would you like to go?
Okay, if you could go towards the telescope, please.
Atlantis, Houston,
And add
for EVA.
another foot.
Hello, Dan.
Yeah, Maz, that's a good point. We'd like to take you up on the BAPS pin and install.
Okay, we'll have Drew go and do that. Drew?
Didn't work.
are you getting off on the telescope, or you want to come down?
I'd like to come down.
Copy, coming down.
Thanks. Actually, Megan, that's a better idea.
What's that, John?
Why don't you just move me over to the right?
Copy, coming to your...
And you can go back up that way. I can just get right back off. Maps pins are installed.
Copy the pins are installed, thanks.
Okay. That's not a good idea. Copy, Drew, thanks. Right.
This is the view from John Grunsfeld's helmet camera as he translates
Okay.
back to retrieve the low-gain antenna cover, which he's going to reinstall over that antenna.
I'm in the LGAP-C. Got it. Yes, I'm going to tether to it. Big waste of time with that captive lock pin, I'll tell you.
What are you going to do?
Yep. Okay, one is open. And for the other one. Come back around.
Hey, John, and yeah, we can see you, WVS. You have a good view, thanks.
John, is there anything I can do at all to help you? I think just pull the BAPS pins when I'm done. Okay. That'll work. And back up.
John Grunsfeld's helmet camera, we see him retrieving the low-gain antenna cover from the Mule, the multi-use logistics equipment carrier, which is aftmost in the payload bay. Now he's making his way back to the area beneath the telescope to install that cover over the low-gain antenna.
I should put my visor down. It's pretty bright, yeah.
John, you need a waist tether there, are you okay?
Okay for the moment, but thanks.
Okay.
I've got that now, ma'am. Thank you.
Okay, thanks, John.
That'll help. Okay, the pit pin's in, ma'am.
Good job.
Okay, I'm going to do a little full check.
Right.
Taking my tether off. Got my tether back. Pushing the plunger. Seems like this was 5 days ago we were doing this.
That's right.
Got to get my tether clear. 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 Yep. It's going underneath. Okay, I'm going back down for the captive lock pin.
Okay.
Thanks. LGAP C installed.
Copy, John.
Alrighty, Drew. You can pull the pins. Set. Get back to the airlock. Set. Pins came out easily again. Megan, can you move further back?
Sure, I'll go further back.
Probably another foot.
Copy.
Okay, the two captive lock pins are engaged.
Copy, the captive lock pins are engaged.
And I'm looking for the arm.
Motion stop.
And maybe a little bit more towards. Actually, if you can come further back and towards starboard, then I can hop off on the mule.
Copy.
John Grunsfeld has finished the extra task of
Telescope.
installing the cover back over the low gain antenna. About 1:35 this afternoon,
From there, Megan.
while retrieving a small piece of debris floating under the telescope,
Sunrise.
Grunsfeld's EMU backpack bumped the low gain antenna and knocked off the very end of it. He reported to the Space Telescope Operations Control Center that he could indeed see copper, and the decision was made to reinstall the cover for thermal reasons. The antenna itself is continuing to function as an antenna.
Okay, John. Hey, Megan, I'm off. Take me towards port.
Plotting is fine. I was going to go back.
And forward. Antenna's clear.
Tether.
My tether is clear. Let me get my waist tether. Sorry, Mr. Hubble. Have a good voyage. Never got your gold thing. Consider it a goodbye kiss, John. Thanks. That's a nice imagery. That's a better way to think of it. Now we truly have deployed every payload. Oh, that's bright. Yeah, I definitely have something to put in my notebook. Yep. Okay. Where are you, Drew? I'm back at the arm base. Okay.
So at least you won't have to see that cover anymore, John.
That's true.
Spacewalkers John Grunsfeld and Drew Feustel now move into Atlantis' airlock. Now 6 hours, 42 minutes into today's spacewalk.
Yes.
Yeah, just want to let you know that that we're feeling real good about this. We think that antenna is going to be just fine. Again, we're getting in receive mode, it works just fine. Expectation is it'll work great in transmit mode too. And there's a lot of happy folks down here on the ground at Goddard, here at Johnson, and all around the world. And we just look back and just kind of marvel at the last 5 days and all the amazing work, electronic brain surgery, and I don't know how else you could put it, that you guys have accomplished on that telescope. And Hubble's never had it better. It's never been more capable, and it's just been a marvel to watch you guys do this.
Thanks so much, Dan. I couldn't agree more. John, remember, take a moment here. This is it, the last spacewalk on Hubble, and maybe our last visit to space. So enjoy this. You earned it.
Thanks, man. I appreciate that. And Dan, thanks for those kind words. I hope we don't lose too many dB, and we really have achieved a lot out here. Thanks a lot, Scooter. And Drew, you're an incredible spacewalking partner. Thanks, John. It's all training. Why don't you come down here and we'll get a real picture in the daylight? Okay. tether's going to go around my back. Yeah, that's okay. You're going in next anyway. So I'll take for it when I go in. Megan, can you go after the payload bay just a little bit? One of them was more. You can see your earth in your visor. Yeah. All right. Cool. Okay, guys, it's going to be good.
Six hours, 45 minutes into today's spacewalk. Atlantis flying 349 miles above the central Pacific Ocean. Spacewalkers John Grunsfeld and Drew Feustel holding their position outside the airlock hatch, letting their crewmates inside get a couple of photos. The next step is for Grunsfeld to ingress. And there he goes. There are 10 to 15 minutes of activities left in today's spacewalk.
A little bit. I'll hook up and go high. Sounds about right.
Okay, John, you will attach your waist tether to the D-ring.
Okay, my waist tether is attached to the D-ring extender. The gate is closed. The hook is locked.
Atlantis,
Copy,
Houston.
and if you can verify Drew's tether config, if you have already done so.
Let's see. He's going to the... I'm grabbing right John onto my waist tether first, right?
Atlantis, Houston on air ground 2.
Yes, I'm sorry. Do that first, Drew, and actually I can see it probably better than John will.
Sure. Can you guys see my clearance to the translation aid?
Yeah, you've got about, I would say 9 inches or so to it. You can probably turn if you need to.
Mask, both gates are closed and locked.
Yes, I can see that. Thank you.
Okay. And I see the same, Drew. Thanks, John.
Port chill for you, Drew.
Okay, on my way.
Atlantis, Houston on 1 if somebody could meet me on 2 for high gain antenna deploy.
Scooter's on his way. Go ahead, Dan, for high gain
I'm
antenna.
going to release my
Yes, Scooter.
Stay
Payload
together.
on 3-11. We're there and ready to go.
slide wire back.
All right. I need to get the cameras set up. I'll do that now. Slide it gently.
I will.
Spacewalkers
Doesn't matter going that way, does it?
John Grunsfeld and Drew Feustel getting ready to come into the airlock and conclude today's spacewalk. In the meantime, Mission Control in Houston has given Commander Scott Altman the word that the Space Telescope Operations Control Center is ready to start deployment of the high-gain antennas. That requires Atlantis to go into a free drift.
Why don't you do it for goodwill?
I'm doing your thing, man.
Yeah, I can see it. It's beautiful, isn't it?
Yep.
It's the way to go inside. Just hang out there for a while. You guys did a great job today. It was wonderful watching you. And good words at the end from both. Enjoyed hearing all of it.
Cut my sign up. Okay, the slide wire slider is reattached to that tether. Velcro is reattached. Secure.
Nice work, Drew. Time for you to go inside.
Going in. Where are we? Anyone?
Say again, I'm sorry.
Where are we?
Hang on.
Out over the ocean?
Yes, over the ocean.
Beautiful. Okay, I'm back in, Drew. Hey, John. Coming into this well. Should have plenty of room.
We're over the Pacific Ocean.
It's a beautiful place.
Headed toward California.
Go surfing.
Drew Feustel's helmet camera view looking up to the end effector of the arm,
Trying to find my feet.
which in fact is looking down toward the Pacific Ocean. Now he's moving inside the airlock. John Grunsfeld already inside.
Okay, boys, for both of you, can open your DCM covers, Velcro them, and then connect the SCU to the DCM and verify that the SCUs are locked.
Is that mine? Yeah. Got it? SCU is on and locked for one. Okay, lights on, working on lock.
Okay, copy on and locked for Drew, waiting on John.
Same deal. A little sticky, I think. Not a good fit to this. But lift that point out and up. Just the TMG tolerance. Yeah, it's pretty tight.
Okay, Houston, those are two different antennas, even though with this view they're both going to be going the same direction.
Yeah.
Scooter, that looks good to us.
Okay, I guess I need to go over to DAP B and then we'll be ready to go.
Yeah, I can wiggle it a little bit.
Okay.
See, we're already
All the way down.
Sounds good, and looks like we're ready for free drift.
Lock.
Okay,
See that little lever go into that hole? Yeah. Oh, down there, yeah.
Commander Scott Altman set up the payload bay cameras to get a view of the two high-gain antennas on the Hubble Space Telescope. In the right-hand half, the dish of the antenna is visible at the very top of the frame above the solar array. Atlantis now gone free drift, and the stock will be sending commands to redeploy those antennas.
Got it. Better write that one up. Okay. Locked, man.
Copy, both of you are locked. Waters off, expect the message.
TV1, waters off. TV2. water off with the message.
Okay, we've got a 2-minute timer going. We cannot close the hatch until then. However, Drew can get the thermal cover.
If you can get your arm out of my... Yes, you.
Both spacewalkers are now back in the hatch. They've turned the water off to their suits. Feustel closing the thermal cover to the outer hatch. Have to wait 2 minutes until, wait for 2 minutes after the water's been turned off before they can close the outer hatch. And once that's done, they can start to repressurize the airlock. That will mark the official end of today's spacewalk. Now 6 hours, 55 minutes in length.
I'll work the tabs a little bit. Go for them.
Guys, we're getting to the last couple lines of all of our checklists that Christy and Tomas worked so hard to put together. At least for the spacewalk part of it.
Yeah, we still got to dress you up tomorrow.
Oh yeah, we still got to do that and post CBA and all that.
That's bueno. Megan, great job today in the arm flying and the IDing. Yep, definitely a team effort.
And Shooter did a great job of coordinating it all on the inside.
Yep, and flying the Noble.
And he flew the arm today.
Okay, all the tabs are secure on the thermal cover.
Okay, those are 2 minutes. You verify that the hardware is clear of the hatch. You've probably already done that. Drew, go ahead and close and lock the outer hatch.
John, does it look clear? Looks clear to me. The only thing in the way is you. And I'm backing up. Okay? I got my hand on your pliff. Pulling you up a little bit. I need to back up a little more. There it goes. Okay. Very nice. Nicely done. Okay, and it might be a little bit engaged. Going closed. Okay. Push hard against it. There you go. It's closed and locked. Hatch is closed and locked, Mass.
I see that. Stand by. We're going to take you to the pre-repress part of the depress repress cue card.
Okay, thanks. I'm there with you.
And I think Bueno's going to talk to you about that.
Atlantis Houston on Air Ground 2, no need to respond. The high gain antennas are deploying.
Houston, we see him out the window, although not on the well, now the display is changing.
I'm going to get a lecture from Ron Sheffield.
Okay, Drew, I'm with you on the top of the pre-repress cue card. We've got the ID steps inside here.
Okay.
John, you might get a lecture, but you might be afraid of getting a bill from him.
Stand by, Matt. Go ahead. Bueno.
Yeah, I'm with you on the pre-repress card. We've got our ID steps 1 and 2 inside. I'm on step 3 with you. Check your SCUs connected to DCM.
BD1, SC is connected to DCM. BD2 and Bueno, you're pretty low volume coming in. I don't know why that is. I hear the same.
Okay, Drew, can you hear me? SCU is connected to DCM.
Yeah, that's a lot better. Yep. BD1, SC is connected to DCM. BD2.
Check water off for 2 minutes.
BD1, water's off. BD2, water's off.
Check outer hatch closed and locked.
It is closed and locked.
Okay, Drew, on the airlock wall, 82 Bravo. Check. 81 and 2, O2 valves, 2 switches are open.
I see the O2 valves open, 2 of them.
Okay, on the other wall, 18 Hotel, power battery charger, EMU 1 and 2, bus select, 2 switches to main A.
Okay, 2 switches, bus select are going to main A. On 1, good power, and 2, main A. Okay, on your DCM, power to SCU, expected tone. EV1, power going to SCU. EV2, power going to SCU. Okay, MET is 1 hour, 18 minutes. Thanks. Day 7. EV1, SCU. EV2, power, SCU. Okay, on to the repress cue card. Both of you on your DCMs, O2 actuator to press. O2 actuator pressed. Is it sticking again, John? No? No. What's up, buddy? Maybe a little. Okay, here we go. Maybe just a little. O2 actuator press, Blaney. Bueno. EV1. EV2. Okay, guys, comm mode to hardline. Comm mode going to hardline. Thanks, Bueno. EV2 out.
And Atlantis' airlock now repressurizing at 2:22 Central Time this afternoon, making the official time for today's 5th spacewalk of the mission 7 hours and 2 minutes in length. Ready to copy.
Houston, standing by for your call for the beat auto.
Checking. And Scooter, I'm sorry to keep you waiting. We're still checking. It'll just be another few moments. So if you got something else, we can give you a call.
All right, well, I'll keep the headset on.
Atlantis Houston, we're ready for auto on the DAP.
Okay, here it comes.
Atlantis Houston for Photo TV.
Go ahead for Photo TV.
Yeah, Scooter, we're going to get the gimbals. If you could pan out, that'd be great.
Okay, panning out to the gimbal.
While spacewalkers were repressurizing the airlock, commanding has now, as you see, got the high-gain antennas of the Hubble Space Telescope out and deployed, expecting motion on the gimbals for the dishes on the end of the antenna booms to rotate within 2 minutes.
Yeah, that's affirmed. Be another minute or so before we start motion.
Today's spacewalk got started at 7:20 Houston time this morning. Officially concluded at 2:22 with repressurization of Atlantis' airlock for a duration of 7 hours and 2 minutes. Today's spacewalk, 7 hours and 2 minutes in length. For the 5 spacewalks on this flight, we have a total EVA time of 36 hours and 56 minutes. Today's was the 23rd spacewalk to service the Hubble Space Telescope. The EVA time in total for Hubble servicing is 166 hours and 6 minutes. Today was John Grunsfeld's 8th spacewalk in his career. He ends up with 58 hours, 30 minutes EVA time. That has him number 4 on the all-time spacewalking list. Drew Feustel's 3rd spacewalk, his career time now 20 hours and 58 minutes. spacewalkers John Grunsfeld and Drew Feustel back inside Atlantis' airlock. It is nearly repressurized to equalize pressure with the rest of Atlantis' crew cabin. As they were repressurizing, we saw the high-gain antennas deploy, the gimbal rotation currently underway. And a note for our NASA television schedule, we're now looking at today's mission status briefing no earlier than 3:15 Central Time this afternoon. Today's briefing from here at the Johnson Space Center in Houston will include STS-125 Lead Flight Director Tony Sacacci, Lead EVA Officer Tomas Gonzalez-Torres, John Morse, the Director of the Astrophysics Division from NASA headquarters, and the Hubble Hubble Space Telescope Program Manager Preston Birch.
Atlantis, Houston, air to ground 1.
Hey, Houston, go ahead. I'm air to ground 1.
Yeah, Ray J, just letting you know we're handing over to Orbit 2. Just one more time, a great day today. A little more words on the antenna. We're thinking it's going to be just fine. No attenuation so far that we can detect at all on the receive mode. We expect it'll work just fine in transmit. It's got a bigger cap is all, and we expect that is zero attenuation through that LGAP-C. So we're real happy with the config.
Hey, Dan, those are great words. I really appreciate you voicing those up now. So thanks for all your support in all of Orbit 1, and we'll look forward to talking to Orbit 2.
You bet. It's been a great day, and we'll talk to you tomorrow.
You bet. I agree. It's a great day.
The fifth of the 5 planned spacewalks on this servicing mission to the Hubble Space Telescope is now complete. It started at 7:20 Houston time this morning. It was finished at 2:22 this afternoon for a total EVA duration time of 7 hours and 2 minutes for John Grunsfeld and Drew Feustel. Today is John Grunsfeld's 8th spacewalk in his career. He now has 58 and a half hours, 58 hours, 30 minutes even, which puts him fourth on the all-time list, the most spacewalk time. His partner on all three of these spacewalks, Drew Feustel, now has 20 hours and 58 minutes to his credit. The other team of spacewalkers, Mike Massimino and Mike Good, spent 15 hours and 58 minutes outside on their two EVAs, the first two of Mike Good's career. This second pair of Hubble spacewalks added to the first pair for Mike Massimino back on STS-109 gives him a total spacewalk time of 30 hours, 44 minutes.
Hey, Scooter, we are ready for the 10-2 maintenance, but we've got a slightly different plan if I'd like to run by you. The maneuver coming up at 0230 would be a non-maneuver if we do it on time to the battery charge attitude. And so what we'd like to get you to do is jump into rotate. We're ready for that now. And then we can pick up those other steps between that have to be done before the battery charge attitude.
Okay, no problem. We can get into rotate right now.
Great. Thanks a lot, Scooter.
I was just waiting for the high gains to finish up.
Hey, Scooter. Atlantis, Houston, sorry we got caught in a handover, and sorry about the miscommunication between the shift handover, but we're done with the high gain antenna gimbals now. They're at 0-0, and we'll pick up the rest of it later.
Okay, that's fine. The next step said something about the tail clear position, so I wasn't sure if we were cleared to rotate if they weren't in that position. But I guess that's just for deploy.
We are clear to rotate. Thanks for double checking that, Scooter.
Okay.
You want to wait for them to finish?
And Houston, Atlantis for the rotate. Do you want the photo TV or do you have enough of that?
Hey, Scooter, good news. Not required today. Thanks.
Okay, that is good. We'll start rotating. We think that we are going to latch for 605.
Copy and concur, Scooter. Thanks.
Today's spacewalk lasted just a bit over 7 hours, and that afforded enough time for spacewalkers John Grunsfeld and Drew Feustel to complete everything that was on their plate, as well as a get-ahead task. They successfully installed the new battery module, the second of those modules installed during this mission, and that battery has passed its aliveness test. A functional testing is coming up later this afternoon. They installed.
And you can understand we're go for 10.2 maintenance if one person does that now.
Yes, Scooter, that's affirmative. And once again, we're going to target 10.48.
That sounds good to me. I like skipping that pre-sleep.
Yeah, that's a big time saver.
And Houston, Atlantis, now that I think about it, we never really discussed this today, but I do want to pass, so we are go for the sleep shifting and the early deorbit.
Okay, Scooter, we'll make note of that, and the PMC will have a couple extra folks in it tonight.
Okay, and we understand that that's going to be a computer-based with imagery PMC.
That's from Scooter. We're planning on net meeting with air-to-ground support for audio, and we would like to do that on time, since it does require KU, if that's okay with you.
Roger that. We'll plan for that on time. And Houston for WLES.
Scooter, go ahead for WLES.
Roger, Dex, we had an inadvertent power down. I'm powering it back up, and it says check MCC as one of the steps. I want to let you know first about the power down, and also if you have any words for me as it powers back up.
Scooter, you're referring to just the PGSC, is that right?
That's affirmative. The PGSC, as part of a power savings effort, got shut down before realizing that one's not supposed to be.
Okay. I'm sure it's no problem. Stand by one. Atlantis, Houston for WLES. No harm, no foul, Scooter. We just need to fire that machine back up and then run the WLES application.
Yeah, it says what backup mode? I think this is the primary, secondary, or standard. It's 6.
Primary works for us, Scooter.
Will do.
View of the Hubble Space Telescope now in its new position in the payload bay. The flight support system has completed its rotation, turning the minus V3 side of the telescope back toward the windows of the crew cabin.
We're looking at minus V3 again.
Copy and concur, Scooter. And Atlantis, Houston for the mid-deck and post-EVA.
Hello, Houston, for EVA.
Mass, great to talk to you. Great job today to the whole team. It's wonderful to watch. For step 32 in post-EVA today, we will take the tank 3 heaters to off, OFF.
Copy, step 32, tank 3 heaters to off, and thanks for the compliments. We had a great day, and appreciate all the help from MCC.
Rotation of the flight support system.
For the dual solar array slew as well.
Scooter, we were just talking about that. As soon as you get as soon as you are happy with the camera config, we're ready for the solar array slew.
Okay, getting it up. It looks like you guys are putting the solar array view up for us. We appreciate it. maybe that's just the way we had the muck set up, and it works out that we're pointed at the solar arrays.
I think so, Scooter. Nice serendipity there.
Parts 1 and Parts 2 of the high-gain deployment commanding from the Space Telescope Operations Control Center is complete. Up next, slewing of the solar arrays back to the 90-degree position. That would move them vertical and into parallel with the axis of the main body of the telescope. Sensor. Both of those pieces of equipment were installed by astronauts John Grunsfeld and Drew Feustel during today's 7-hour, 2-minute-long spacewalk. They also completed the installation of the new outer blanket layer insulation on the Bay 5 door, as was part of their plan. In addition to that, they installed the Noble on Bay 8, the task that was bumped off of yesterday's spacewalk.
That view looks like what you want. Atlantis is ready to go free drift on your call.
Copy, Scooter. Stand by 1.
And after that, they installed the Noble on the Bay 7 door. That was a get-ahead task on the agenda for today. So all of the tasks plus get-aheads done today during a 7-hour, 2-minute-long spacewalk. The total for the 5 spacewalks on this flight, 36 hours and 56 minutes worth of servicing work done by 2 teams of spacewalkers over the course of the last 5 days. A few minutes ago, we also heard Commander Scott Altman advise Mission Control that the crew was go for the sleep shifting and go for the early deorbit. That is to go along with some planning that's been underway here in Mission Control for several days, looking at adding an earlier de-opportunity this coming Friday. The thinking being that wanted to take the opportunity to try to get Atlantis on the ground earlier in the day before sea breezes at the landing site kick in. Those breezes often induce more showers, and that might lead to a weather wave-off for the planned Friday landing. The mission management team had approved of the plan pending agreement from the crew, which now has been received, to adjust the schedule for the for burns that will come up following deployment of the Hubble Space Telescope tomorrow. And those exact times for all of those burns and for the landing are being recomputed. But the plan is essentially to have 3 landing opportunities on Friday morning at the Kennedy Space Center in Florida, adding an opportunity 1 rev earlier than the nominal end of mission timeline, which would, if it were taken advantage of, would put Atlantis on the ground slightly after 9 a.m. Central Time on Friday morning. Once again, the exact times for landings and for a series of burns are being recomputed at this time, and we'll make those available as soon as they are known to us.
Atlantis, Houston. Scooter, we are ready for free drift on the depth.
Okay, here it comes.
In this video, as the Atlantis flies in orbital nighttime over the far southern Atlantic Ocean, payload bay cameras are aimed at each of the 2 solar arrays on the Hubble Space Telescope. Mission Control has just given Commander Scott Altman a go to go back to free drift, and commanding now to slew the solar arrays, to rotate them back into the vertical position, to have the length of the solar arrays parallel to the axis of the body of the telescope.
Atlantis, solar array motion in 30 seconds.
Copy, we see the message.
Atlantis, Houston, for switch 0 on MO10W.
Okay, ready.
I would like to take 14.7 cabin reg inlet system 2 to close, and then you can open system 1.
Ooh, okay, we got it.
Thanks. Atlantis, no action on the O2 concentration.
Thanks, Houston.
video is dark, but it's clear that the solar arrays are indeed being rotated into the 90-degree position, moving the long axis of the arrays into be parallel with the axis, the long axis of the Hubble Space Telescope itself. Once this solar array slew is complete, the Space Telescope Operations Control Center will move on to commanding to conduct the functional testing of the new battery module installed during today's spacewalk by astronauts John Grunsfeld and Drew Feustel. That new battery module of 3 batteries passed its aliveness test after its installation this morning. Into later in the afternoon and into this evening, the stock will also send commanding to do a functional test on the new fine guidance sensor, also installed this morning by spacewalkers Grunsfeld and Feustel. The new fine guidance sensor, it also passed its aliveness test this morning. A pair of spacewalkers completed the planned installation of a new outer blanket layer of insulation on the Bay 5 door. And on top of that, they installed a new Noble on Bay 8, the task that was bumped off of yesterday's spacewalk timeline, and a new Noble on the Bay 7 door, which had been a get-ahead task on today's spacewalk. All of that done within the space of 7 hours and 2 minutes. That time also included an additional unplanned activity as the crew members reinstalled a cover over one of the low-gain antennas on the bottom of the Hubble telescope. As the spacewalkers were wrapping up their activities, they noticed a small piece of debris floating under the telescope. As John Grunsfeld retrieved that debris, he also inadvertently tapped the low-gain antenna with his spacesuit backpack and knocked the very end of that antenna off. The Hubble Space Telescope Mission Control asked if he was able to see copper after he had knocked it off, and he replied that he had. They then decided to ask, and Grunsfeld and Feustel moved to reinstall one of the thermal covers on the low-gain antenna. The antenna itself is still functioning properly. The choice was made to reinstall that antenna to help protect to reinstall the cover in order to protect the antenna from the thermal changes that it experiences at that orbit. In fact, within the just a little over a half an hour ago, spacecraft communicator Dan Burbank relayed to the crew that the stock reported that there was no attenuation from the low-gain antenna through the cover. It's still functioning fine. It now has an additional thermal protection in the mode of this thermal cover that is now in place.
Atlantis for EVA actions on the flight deck.
Go ahead, Scooter.
Yeah, and the step on R1 for the O3 heaters, I'm guessing you're ready for those to come off.
We're ready for that now, Scooter. Thanks.
Okay, and then we're doing the set contract.
Copy.
Houston, Atlantis for EVA.
Bass, go ahead for EVA.
Hello, Dex. Just double checking about EMU water recharge for John and Drew's suits. Do you want us to recharge those?
Mass, that's from
We're guessing probably yes, but we want to double check.
Yeah, we do. Thanks for asking, Mass. We'd like to get those recharged.
Okay, we'll do that.
Atlantis, Houston, for Scooter, after you get the NBAT loaded, we'd like to hold off on the contraction until after the solar array slew is complete.
No problem, we'll do that.
Thanks.
Video from Atlantis' payload bay cameras showing the slew of the solar arrays on the Hubble Space Telescope just about complete. Have them back in what is known as the 90-degree position. And that will, once that's done, the Space Telescope Operations Control Center will move on to begin the commanding of the for the functional test of the new battery module installed during today's spacewalk. We're also standing by for the start of today's mission status briefing. We'll feature STS-125 lead flight director Tony Sacacci, Tomas Gonzalez-Torres, the lead spacewalk officer for the mission, along with John Morse, the director of the Astrophysics Division at NASA headquarters, and Hubble Space Telescope program manager Preston Birch.
Houston, looks like we're down to the point of your call for DAP back to auto.
Scooter, we're just about there waiting on a call from the stock.
Okay, and then we're wondering when you'd like us to select DAP to A for the future loaded maneuver.
Scooter, when we get to back to auto at the end of this slew procedure, we'll do that in B11. Then as soon as we get into attitude, you can load DAP A10.
Okay, well, when you give us the go, we'll select the B auto DAP. We'll monitor, and once we see ourselves in attitude, we'll go to A10.
It's a good copy, Scooter, and we'll back you up on that as well.
Yeah, thank you.
And Scooter, we are ready for auto on the DAP now.
Okay, we got auto on the DAP.
And we do see a good end bet. You're also good to continue the contraction.
Okay, we'll do that next.
Slewing of the solar arrays in the Hubble Space Telescope back to the new position. The 90-degree position is complete, and Atlantis resuming attitude control. And we are ready with today's mission status briefing from here at the Johnson Space Center, featuring the lead flight director, lead EVA officer, and the Hubble Space Telescope programming manager, along with the director of astrophysics from NASA headquarters. That's up as our next event on NASA television. This is Mission Control, Houston.
Well, good day and welcome back to the Johnson Space Center for today's mission status briefing on Atlantis' flight to the Hubble Space Telescope. Certainly an historic day today. With us to talk about all the activities associated with the final spacewalk are Tony Sacacci, the STS-125 lead flight director, Tomas Gonzalez-Torres, the STS-125 lead spacewalk officer, John Morse, the director of the Astrophysics Division at NASA headquarters, and Preston Birch, the Hubble Space Telescope program manager from the Goddard Space Flight Center. We'll start off with Tony.
All right. Thanks, Rob. It's kind of different being here so early in the afternoon, but really enjoyed it. As you noticed this morning, when I talked to the crew last night, they were really excited about today's EVA, and you could tell by this morning they got an hour ahead of the timeline, and we got an hour out the door, an hour and ahead, which in turn led us to be able to complete all the activities, not only that were our mission objectives, but one added Noble 7, which the HST guys I know really appreciate. Again, a really great day. Everything went really smoothly. A couple hiccups again, but again, the crew reacted very quickly. You know, you keep hearing me say this, but again, another tremendous team effort. I'm not going to go through a very long speech because we still have one more activity to go through tomorrow in the HST deploy, and then maybe tomorrow I'll add a few more words. But again, you know, when I came in here, I didn't have much written down, but it was kind of like both a sad day and a very happy day. After we repressed the airlock, Tomas and I kind of looked at each other because we knew that that was the last planned EVA out of the shuttle airlock. I'm sure a lot of folks didn't know that, but we we'd thought, you know, kind of look at each other and go, wow. And also, you know, we've been working together on the EVA front for about 2.5 years, putting this all together. And as I went through the Blue Ficker and talked to all the HST guys and Seppi and John and such, it's kind of like you go, wow, you know, this is really over. We waited this, and you don't really know what to say, but to congratulate each other on a super effort by all the different folks. Like I said, the crew's getting done, of course, with post-EVA activities. We will be setting up a couple suits for the Mike and Mike team, just in case we had to do any rapid response EVAs, if we had any deploy contingency for tomorrow. But with that, let's see, I'll pass it out to Tomas.
Thanks, Tony. EVA duration for the final HST servicing mission EVA ever is 7 hours and 2 minutes. If I did the math right, that's a total of 36 hours and 56 minutes total of EVA duration for all 5 EVAs together. Like Tony said, another excellent EVA. We completed the final batteries, FGS changeout, and a little bonus on the Nobles. We got all 3 of them. Again, there's really not much to say, but like Tony said, it's bittersweet. You know, last servicing mission, last EVA, and I guess I just wanted to thank the excellent teams that I've had an opportunity to work with, both on the JSC side, the Goddard side, my task folks, Christy Hansen, Bridget Scheib, and on the EMU side, Ed Tom and Paul Dum. But it's really been a privilege getting to work this mission, and I think that's about it, actually. So I'll go ahead and hand it over to John.
Thanks, Tomas. With the completion of today's EVA, Hubble is returned to flagship status. And it now has a full arsenal of instruments instruments and tools for astronomers to use to make the new discoveries during the next several years. We want to thank, again, everyone involved in this endeavor. So on behalf of the Science Mission Director, I want to thank the SOMD Space Shuttle Program, all the folks at Johnson, these gentlemen up here on the panel, Tony and Tomas, thanks very much. Of course, the astronaut crew, without whom nothing would have been done. KSC, all the folks that got the shuttle going. I want to give kudos to the HST program, and Preston, who's sitting here, some other folks in the audience, all the crew at Goddard, all the contractors that have supported this endeavor, who have been planning for many years and sticking with the program to make it a success. Now, we've met our objectives in this mission, and you know, it is bittersweet, as folks would have said already. I'll let Preston and some other folks speak the eloquent words. You heard some from the astronaut. But we have a saying in the Science Mission Directorate: science never sleeps. And our work is just beginning. And we can't wait to get out there and use Hubble for its intended purposes. We have literally thousands of astronomers out there around the world waiting to use these new capabilities, and they're chomping at the bit to get their data. So with that, let me turn it over to Preston.
Okay, thank you, John. Today, the feeling on the HST program must be what it's like to be on a team in the National Football League when you win the Super Bowl. We're just so tremendously pleased and excited with the outcome of this mission. As those of you who have followed us through the past 5 days can tell, working in space is a difficult challenge, and it's often a very fine line between things that look easy and things that look to be almost impossible. And it's a great testament to our team of spacewalkers: John Grunsfeld, Drew Feustel, Mike Good, Megan MacArthur, Mike Massimino, and of course Ray J and Scooter. They just never gave up, and I'd have to say that right now, one of the things that they refer to us as down here, at least publicly at JSC, is the customer. And I think the customer's expectations have been exceeded on this mission. When we came into this, we had, on the previous 4 servicing missions, we had 18 perfect EVAs, and that's just really tough to exceed, to look at that. You figure something's going to go bad, at some point something's going to fall off the plate. And the team on orbit just powered through it, and here we are. We've accomplished more than we actually expected to accomplish. And so I want to say thanks to Tony and your fantastic team on the ground, to Tomas. I mean, this, it takes literally thousands of people to put a mission like this together, from all the various NASA centers, industry, academia, and without the continued interest and support from the public, of course, missions like this don't just happen. So I want to thank everybody. And now we're looking forward to getting on with deployment and commissioning our renewed observatory, and looking forward to several years of really great science and exciting discoveries. So thank you very much.
Thanks, Preston. We'll take questions here in Houston, and we can start in the back there with Mark.
Thank you. It's Mark Carreau representing the AFP, and I believe this may be for Preston Birch, but could you sort of review for us the commissioning period and kind of the point in that process when the astronomical community gets to start observations with the telescope again?
Okay. The period in question is called SMOV, S-O-M-V. That's SMO, Servicing Mission Observatory Verification, SMOV. And we plan that out pretty conservatively. There's about 4 months of pretty intense activity with getting the new equipment checked out, getting the new instruments aligned and focused and calibrated and so forth. Our plan is to have early release observations, as we call them, in the early September timeframe of this year, and we'll have a press conference to reveal those to the public. And so I would say for the first few weeks here, for the next several weeks, there isn't going to be much in the way of real science going on, because we've got 2 new instruments and two instruments that have been repaired, and so there's a lot of work associated with getting those online. But I would say after a period of several weeks, we'll start taking some worthwhile science observations and continuing to fine-tune and check out the instruments. And then when we get to the early September timeframe, by the time those EROs come out, we'll be hitting full stride in terms of producing science in accordance with the Cycle 17 observers that are going to be using the observatory over the next year.
And for Dr. Morse, can you sort of characterize how many teams, or however you all account for it, are sort of out there now in this Cycle 17 waiting to pursue some investigation with Hubble?
Oh, we can get you precise figures later. What Hubble has an annual call for proposals, and the excitement of using the instruments after SM4 was very high, and I think the oversubscription of the time, at least, and the commodity is orbits that the astronomers compete for. It's usually at least 5 to 1 oversubscribed, and probably time-wise more like 6 or 7 to 1 this time around because of the extra excitement. I think of order 800 or 900 proposals come in with, at least several and sometimes dozens of scientists on each proposal. That gives you an idea of how many people would like to use Hubble in the worldwide community. And then of order 200 or so of those are selected. So you have to be, better than the top quartile. and a lot of very good proposals wind up being declined, unfortunately, but there's only so many orbits in a year.
Bill Horowitz, CBS News, with two. One for Tony. Can you go over the orbit adjust plan for me and what you're doing and why you want to get the extra orbit opportunity and the thinking that went into that?
At first, we, at the 300 nautical mile orbit, we have a larger flux field and the MMOD and concerns of that. So our first reason we're going to do the orbit adjust is go down to about a 160 perigee, and that way you kind of average your altitude like if you would be in a station flight. And also, Norm Knight, the entry flight director, is looking at trying to get a rev early as far as coming into KSC, because about the time at the time we plan on landing at KSC is when the sea breeze effect takes, or the sea breeze effect occurs. So where the clouds, build up and possible rain in that. So he's just looking at trying to get an earlier opportunity for that. But the main reason for MMOD and the secondary reason was to get a rev earlier opportunity at KSC.
Thanks. And a quick one for Preston. Would you refresh my memory on what you guys used the low gain antenna for and what your status is of that after it got bumped?
Okay, there are actually two low gain antennas on the observatory. There's one up at the top of the observatory, or the forward end, near the aperture door, and there's one on the aft bulkhead on the aft shroud. The two together provide total hemispherical coverage. So each of them individually provides only half of a hemisphere, and we can only use one at a time. So we have to have some rough idea of which way the observatory is pointing toward the tracking and data relay satellite system or toward a ground system. Typically, these low gains are only used during emergency periods when we don't have access to the high gain antennas. If we have a loss of control on board the observatory, we go into a safe mode, we stop driving the high gain antennas, then we switch to the low gains, and it's low rate engineering data that's coming down so that we can observe the status of the observatory and start working toward getting it back to normal science operations.
And it's okay?
Yeah, this low gain antenna, we use it when we're in the payload bay through the payload interrogator on the shuttle, and we've made some performance measurements after the incident that occurred, and we have a cover that we placed over top of it, and it's working fine. The cover that goes on it is RF transparent, and we always protected for a possibility that we could be rapidly deployed overnight with that cover on, because we don't take that cover on and off every day. We put it on at the beginning of our EVA activities, and we'll leave it on until the very end. And so it's perfect. So we designed it so that we could fly away with it on, and now we actually have a good use for it. So no problem.
Frank?
Frank Mooring with Aviation Week for Preston, and I think I'll have a follow-up as well. Over the last 19 years, you've probably learned a lot about how to maintain a spacecraft with human support over time. Could you give us some of the lessons, some of the big lessons, some things you didn't know at the beginning that you know now?
Oh, wow. Where do I start? Let's see. I think one of the things that we learned, and of course I think we knew this in the beginning, but we've really seen the tremendous benefit from using things like the Neutral Buoyancy Laboratory to rehearse our EVAs. That has been just absolutely indispensable to the success of this mission. Another thing we learned is the value of the specialized tools that we've built for various things to make the astronaut spacewalkers more efficient and effective in what they do. One of the great things that we developed was the PGT, the pistol grip tool. Initially, there was some reluctance, I think, on the part of, I've been told, by some astronauts to want to use it, but after they get out there and they've worked for several hours, the tremendous savings in energy from that was just incredible. So I think we've learned a lot, primarily in the tools area. we've also learned a lot about how to orchestrate or choreograph these EVAs. Tomas, you probably ought to be talking this. I feel like I'm giving your speech here. That has been a huge benefit, and we really learned a lot on servicing Mission 1, especially with Story Musgrave, who was the payload commander. He really understood from the outset the importance of choreographing, of not wasting any effort, whether it's an arm movement, a leg movement, going from one place to another. You make every single movement count, and that's why we can do so much in such a very short period of time. So those are some of the things we've learned. Another thing that we've done, and that we're real good at, of course, is very thorough lessons learned after each mission, so that we avoid making, you never want to make the same mistake twice in anything that you do, but it's really critical in EVA activities. And so we document that stuff, and whether it's things we're doing on the ground or things we're doing on flight, we disseminate that and work real hard at that.
Last night, Tomas did say that this is a real illustration of the importance of humans in space. With the genius of hindsight that you've gotten this afternoon, how much of this mission could have been done by a robot and using today's technology?
I think robots would have been hard pressed to do what the humans have done. I mean, like wrenching that handle off of the cover the other day in order to gain access. I think that's a good example of improvising on the spot and dealing with problems. I mean, there's been a number of surprises along the way, but the adaptability and the speed with which humans can react to things in situ, as these things happen, are important. The thing about robots is that in order for the robot to be effective, the thing that they're working on needs to be built. The interfaces need to be built with the robot in mind, and when they're not, and Hubble has not been, then a lot of very clever tooling needs to be put in place, and it becomes, I think, a real challenge in the tools area and in robotic design and in software to do that. And we've had, we worked on a robot mission for quite a while, and as we attacked some of the basic things that needed to be done, like gyros and batteries, we moved on to things like changing out instruments, and that started to make some of the people in high management positions at NASA nervous about the cost and the risk associated with that. And then as we moved beyond that, we started getting into instrument repair, and I think we showed that it was potentially feasible to do this sort of thing, but it hasn't really been demonstrated, I think, sufficiently to the point where you can make a commitment to a huge program. So I mean, a better approach would be to design the thing that's going to be serviced by robots, design it and deploy it first with robots in mind, rather than trying to back into it.
Gina Sinceri, ABC News. I have two questions. Preston, I mean, there's a capture mechanism now for something to go up and get Hubble and deorbit it. How's that planning going?
We got a head start on that planning, actually, when we started working on the Hubble robotic servicing and deorbit mission. We had a propulsion module that was designed. At the time, we did not have the soft capture mechanism that we have on board Hubble now. This soft capture mechanism that we just installed uses a system known as LIDS, Low Impact Docking System, which is intended for future NASA missions. Now, it's probably not, the future NASA missions will probably have some design dimensional differences, but the technology there exists, and so it'll be easier to rendezvous and dock with Hubble in the future. That was one of the things we had some concerns about with the robotic mission that we were working on, and actually what we knew that the robot arm grappling works very well. As you can see, when the orbiter comes up and the RMS is deployed, we grapple the grapple fixtures. So that was the technique we were going to use on the Hubble Robotic Servicing and Deorbit mission, and then use the arm to bring the servicing vehicle into dock with the berthing pins or towel bars that are located on the aft bulkhead. This will make that kind of docking a less risky and more certain affair in the future. Right now, the thinking is we would probably send an expendable launch vehicle up with a propulsion module to dock with a soft capture mechanism, and then we would control that from the ground. But we have a lot of time before we have to worry about that, because Hubble's orbit, rate of orbit decay will leave it up there till well past 2020.
And for Tony, you've had some surprises on this mission. Have you thought about like trying to do a fly around of Hubble, or it's just not going to happen?
It's not going to happen. We got as good a view as we can right in the payload bay.
Thank you. Irene Klotz with Reuters. I have two quick ones for Tony and one for Preston. Tony, how far along will Mike Massimino and Mike Good be prepared to do a contingency spacewalk tomorrow?
They're going to go all the way through prior to EMU dawning. So they'll just have like their LPCGs on and all hooked up with biomed and everything.
So like how many hours?
Probably 30 minutes into it.
Okay, thanks. And when do you release the STS-125 crew from being available?
The way I understand it right now, it's after we get our post-late inspection, we get the imagery review. I understand that they're talking about keeping it available until post the deorbit burn, but I hadn't really been following it. I've been kind of focused on what we're doing here.
Okay, thanks. And for Preston, are you planning at all to try and work on the NICMOS problem during the commissioning of the other instruments, or are you going to be waiting until the new instruments and the repaired instruments are working before you get back into that?
Well, our first priority is to get the new instruments going and the repaired instruments, but we're going to try to work in getting the NICMOS cooling system cranked up again as time permits. So as we have opportunities in our SMOV timeline over the next few months, we're going to try to get that going again, but we're going to be priority driven.
Thank you. This is Tarek Malik with Space.com and Space News. I have, I think, one for Preston and one for Tony. Preston, tomorrow is Unberthing Day, and it's the last time that folks are going to at least have a remote grasp of the Hubble telescope. But I'm wondering, I guess, what your team is going to be feeling tomorrow, and then do you change anything in how you operate the telescope, knowing that no one will be there to change things out?
Well, as Tony indicated earlier, there's already some bittersweet feelings. You know, we're extremely pleased with the success of this mission and just incredibly happy. And on the other hand, a little sad that this is the last time that we will see it, last time that we'll have an opportunity to maintain it and upgrade it and keep it going. But I think we all recognize that, you know, we've gotten almost 20 years of service out of it, and it'll be cranking along there for another 5 years, that maybe it is time to move on. And there's a lot of great programs coming down the pike, which John Morris, I think, has talked about in the past. So we've learned a lot over the last 19 years on how to operate and take care of Hubble. During the period when we weren't certain whether SM4 would actually happen, we went into a very intense life extension initiative program, and we made a number of improvements in our ground operations, you know, with how we operate various systems on the observatory to maximize their lifetime. And so we're going to be using a lot of those techniques and lessons learned to try to get the most out of this observatory for the next several years.
Thank you. And then just a follow-up for Tony, you mentioned that this is kind of the last spacewalk out of the shuttle's airlock, and it's pretty much the last unmanned satellite servicing for the shuttle, which was one of its major purposes. So I guess tomorrow, what your feelings are kind of on that milestone, knowing that the only destination now for the shuttle before retirement is to the station. Thanks.
Well, you know, the station is our future, and you know, we knew all this was coming. It's just Shirley didn't want it to come, you know, as soon as it did. But again, you know, it's a sad moment, but it's a great moment because, you know, like everyone's been saying, we put the Hubble in the best posture and performance that it could ever be in, and what a good way to do your last, you know, shuttle EVA, and what better than with the Hubble. But I mean, again, on the station's our future, and we'll just continue to press on there.
Robert?
Robert Perlman with Collect Space. It was said earlier, possibly for Preston, it was said earlier that the telescope had returned to flagship status, and over the course of this mission, we've seen a lot of instruments put in, put out. Is it fair to say that Hubble is not the same spacecraft it was in 1990? Is it a brand new machine, or does it carry forth the legacy? And if you can, because I think it was said that it was easier to say what was original than what was new. Is there any, other than the primary mirror, is there anything of substance that's of original on Hubble?
Yeah, there's still a lot of original equipment, and if you want to know what some of the things are that I think about it, and you know, when I'm thinking about Hubble before I go to sleep, it's things like the high gain antenna gimbals. Okay, those are mechanical devices. They're the original ones. When the high gain antennas stop tracking, that's going to make it a challenge to get the volume of data down to the ground that we're presently able to do. Knock on wood, they've been working extremely well over the entire history of the observatory, and of course we do have two of them. But things like that worry me a little bit. We have the original data management unit in the observatory, and there's several hundred components in there that are still part of the original equipment. But we've made huge upgrades to it. I mean, the electrical power system has been totally rebuilt. We're on our third set of solar arrays. The gyroscopes we've replaced on several occasions. So, you know, the known wear out items, you know, we've done a great job in taking care of. And a lot of the things that we have put on board are vastly improved over what the observatory what the original equipment on the observatory was. For instance, the tape recorders. When we launched, we had 3 what we called ESTRs, ESTRs, engineering and science tape recorders, and these are reel-to-reel tape recorders. That was the state of the art when this thing was designed and built back in the 80s. And you know, after a while, these things usually wear out and have problems, and we replaced 2 of those on previous servicing missions with solid-state recorders. The arrays have gotten smaller in size, which has reduced our ballistic coefficient, and so it's sort of like getting a free reboost out of the space shuttle. But we're getting 30% more power because we're using gallium arsenide chips on the arrays. So things like that. We've made a number of product improvements in the gyroscopes, so we're hopeful that those are going to continue to do better. And I think this last group of gyroscopes that we pulled out had some of the earlier product improvements, notably in the fluid that's used in them and the process for that. It's one of the reasons why they've lasted as long as they have. You know, we attacked the flex lead problem. So and then of course there's the instruments themselves, which are just orders of magnitude more capable than the original instruments that the observatory was launched with. So in many ways it is a brand new observatory and far more capable than Hubble of 1990.
Eric.
A couple of questions. First of all, can you maybe update us on the overall status of the aliveness and functionality tests of each of the instruments? I think there was a problem with the advanced camera for surveys, but I just wanted to sort of make sure I understood that.
Okay. The wide field Camera number 3 is fully passed its aliveness and functional test. The Cosmic Origins spectrograph, same thing. It's AT and FT, fully successful. The ACS repair, we completed that aliveness test and functional test. So everything's looking very good that way. And on the STS repair, we passed the aliveness test, and in the spirit of full disclosure and transparency, as we say today, I have to admit we made some minor mistakes in the functional test checkout plan, and so we've had to restart that a couple of times. So we're still working our way through that. But what I can tell you is that the thing that we were primarily trying to restore was the mechanism power. That was what we had lost when we had the failure in this particular area of the electronics, and we know that has been restored, and there's no reason to believe that the CCD and the MAMA detectors aren't as they were before. So we have full expectations that when we complete the FT that it'll pass with flying colors.
And then secondly, I know this is difficult, but could you maybe sort of quantify or in some way, use an analogy to show how much more powerful Hubble is expected to be now than it was when it was launched and fixed, I guess, in 1993? Like a microscope, you can say it's gone from 50-time magnification to 100-time magnification. I don't know if there's something you could say to sort of just show how much more of an improved instrument this is now than it was, I guess, 16 years ago.
Well, there's a couple of ways to look at it. One, this is the point where Dave Leckrone, I would normally defer to Dave, who's in the audience, but there are several parameters you can look at. Number one, you can look at the number of bits that are being brought down to the ground, and the more data you're bringing down, the more opportunity there is to discover new things. So in terms of the data volume, Hubble after SM4 versus Hubble at launch, the increase is on the order of a factor of about 30 or more, okay, depending on which group of science instruments you're operating with. Another area to look at is in terms of wavelength coverage. When Hubble was first launched, it did not have a near-infrared instrument in it, and now we can look in the near-infrared. So we have full spectral capability for, I can't really say for the first time because we had it when NICMOS was installed, but in terms of sensitivity, the instruments are far more sensitive, and John, you probably have a better command of the numbers than I do in terms of the various instruments and their resolution and their...
Right. Typically, when we have a next generation instrument, it does an order of magnitude better than the previous. And so you have combination of larger detectors, more sensitive detectors, and then with wider wavelength range.